Hello, Kim 1. I wanted to go ahead and do Avogadro's law for us today. And I made a mistake on the previous video. I just happened to catch that now. In terms of the combined gas law, I call it ideal gas law. It is not ideal gas law. It is combined gas law. The ideal gas law is what I'll be showing you later. So I really felt bad once I realized I'd done that. So I apologize. Under Avogadro's law, I'll just be honest with you, it's not one that I use very often. In fact, I rarely have taught this. Other Chem 1 teachers were using it, so I decided I would stick in line with that. And maybe it'll help us when we're learning to do the ideal gas law. But that being the case, I'm doing everything I can to help you learn this. But Avogadro's law is essentially looking at the volume and molar relationship. You may remember from at standard conditions, 1 mole of any gas occupies 22.4 liters. Well, what we're going to learn in the ideal gas law is how to deal with that when it's not at those conditions. But for right now, we want to look at this particular law. And you again pick 4 of the problems out. There's 8 of them there. Pick any 4 you want except for number 2. Number 2 is the one that I'm going to work on right now. So let me write that down, number 2. Now, I think number 2 is the hardest problem on the worksheet. Okay, it says 1.6 grams of oxygen has a volume of 188 milliliters. What volume of 8 grams of nitrogen gas has the same at the same conditions? So this formula, again, just when you're doing these laws, write down the formula for every one of them and then solve for what you need. So it says what volume? So we're trying to find V2 in this particular one. So V2 equals V1 over N1 and times N2. So V2 equals, now V1 was given to us at 188 milliliters. N1 was given to us as the grams of oxygen. And then N2 is given to us as 8 grams of nitrogen. You say, wait a minute, how in the world can I relate 2 different gases together? Remember, Avogadro's law states that a mole of any gas is always going to occupy the same volume as a mole of any other gas if pressure and temperature are the same. And that's all, since that's all we're dealing with here, then we'll say pressure and temperature is the same. So what I have to do, and I know this is going back a ways, and remember I told you keep track of units, we have to convert our grams to moles. Okay, so grams must be converted to moles. So let's do oxygen first. It really doesn't matter. These are also hard because they're diatomic. So it's O2. So it's 32 grams of oxygen per 1 mole of oxygen. And then if you look up nitrogen, it's 14.01. So it's 28.02 grams of nitrogen to 1 mole of nitrogen. So you can see grams of nitrogen cancel, grams of oxygen cancel. And I know that this is nitrogen over oxygen, but again, any gas is okay with that. So moles cancel, and we're left with milliliters. Now, there was a mistake made on the key, and that's why I want to do this for you. So let me see if you can probably can't see this real well, but it's 188 times 8 times 32 divided by 1.6 and divided by 28.02, and I get 1073.5. But if I go back to the original problem, there's only 2 significant digits. So it'd be 1100 milliliters of nitrogen. That was the gas we're after. And on the key, it had 110 for those who started early, but it's actually 1100 milliliters of nitrogen. And so on the other problems, most of them are already in moles. A couple of them you have to convert, but if you're picking them, you don't have to pick those, but you may want to pick one of them just to give you an opportunity to look at that. So this is how you do Avogadro's law. I hope this is clicking okay for you. Keep the emails coming. We'll go from there. All right. Thanks.